The James West Space Telescope has spotted 6 rogue planets without a star to call home. We think of planets as the inherently confined children of host stars. Space, however, is a strange and mercurial thing. Objects do not always follow the rules we think they ought to. In using James West Telescope, astronomers caught 6 rogue planet-sized objects, zooming untethered to any star, wild and free through interstellar space, in the gorgeous environment of star-forming nebula in the constellation of Perseus. We're probing the very limits of star formation process, says astrophysicist Adam Langeveld of Johns Hopkins University. If you have an object that looks like a young Jupiter, it's possible that it could have become a star under the right conditions. This is important context for understanding both star and planet formation. There are a couple of ways we can build a cosmic object. Stars are thought to form top-down. A clump in a suitably dense cloud of dust and gas collapses under gravity and accumulates more and more mass from a disk of material that swirls around it until the pressure and heat at its center are high enough to ignite hydrogen fusion. At least some planets are thought to form from a bottom-up process, from the material left behind in the disk when the star finishes forming, and in this scenario, clumps of material start to stick together electrostatically, then gravitationally, eventually building up enough material to form a differentiating core and mantle. It's unclear where the boundary lies between these formation mechanisms, and it was this question that drove the researchers to point James West at a nebula called NGC 1333 in Perseus, a region filled with clusters of young stars newly formed from the gas within. We use Webb's unprecedented sensitivity at infrared wavelengths to search for the faintest members of our young star cluster, seeking to address a fundamental question in astronomy: how light an object can form like a star, says astrophysicist Jayawardhana of Johns Hopkins University. And it turns out the smallest free-floating objects that form like stars overlap in mass with giant exoplanets circulating nearby stars. Astronomers estimate that there could be billions of rogue planets drifting through the Milky Way. A large portion of these would have formed in the usual way, in the leftovers of the meal devoured by a baby star. Hectic gravitational interactions could free these worlds of their stellar moorings and send them off to have star-free adventures or become ensnared by the gravity of an alien star. But it's possible that some rogue planets start their development in the same way as stars do. We know a population of objects that form like stars but don't get enough mass for hydrogen fusion. These are the brown dwarfs, between about 13 and 85 times the mass of Jupiter. These objects are massive enough to support the fusion of deuterium, a form of heavy hydrogen whose fusion requires low pressure and temperature. They glow, but they glow dimly. Modeling suggests that the upper mass limit for the planet to form bottom-up through core accretion is less than 10 Jupiters. And in addition, the population of NGC 1333 is young, and such accretion would take a bit of time, as would the gravitational interactions that would yet meet out the big wide galaxy. So when James West spotted 6 objects between 5 and 10 times the mass of Jupiter, Langeveld and his team thought they must have formed from gravitational collapse. This was confirmed when they found disks around each of the relatively tiny objects, just like baby stars in miniature. Jayawardhana says, our observations confirm that nature produces planetary mass objects in at least 2 different ways, from the contraction of a cloud of gas and dust, the way stars form, and in disk of gas and dust around young stars as Jupiter in our own system did. Interestingly, although James West Telescope is sensitive enough to detect even smaller objects, the researchers found no rogue world smaller than 5 Jupiters. That's still huge, of course. This suggests that this is the cutoff point, and below that mass it's likely planets need to form via core accretion. The team's findings suggest that these objects are plentiful, accounting for as many as 10% of all objects in the cluster they studied, and the discovery of these worlds suggests fascinating possibilities, blurring the line between a star and its planets and a planet and its moons. Those tiny objects with masses comparable to giant planets may themselves be able to form their own planets, says astrophysicist Alex Scholz of University of St Andrews in the UK. This might be a nursery of a miniature planetary system on a scale much smaller than our solar system. The research was accepted into the Astronomical Journal, available on ARXIV, and this is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.